So one of the options for Unit 13 is to look at sentiment analysis. And that's what we'll do in this notebook. So sentiment analysis is trying to extract some meaning, simple meaning from text, processing text. You'll start in this notebook, both these options for this unit, start with an introduction to a new topic, and you'll read a couple articles, watch some videos, and answer some questions related to those. So in this one, we're going to have you start with this introduction to sentiment analysis. And again, we're talking about assigning some meaning to text. Currently, sentiment analysis, a lot of the basic stuff is just not trying to, really understand the full meaning of text, but just try to tell if it's like positive or negative reviews, or assign some simple meaning to it as far as that goes here. So let's just walk you through what sentiment analysis does and kind of the basic types of it for this. So that's the first part. Then there's this video from Google on Zero to Hero as part of their machine learning training course, talking about language processing here. This actually, this is part 3. Part 1 and 2 actually do some of the stuff we've already talked about in this class, and 3 talks more about sentiment analysis and how we assign tokens to data. And one of the challenges is, how do you process words, and do you worry about reading any one character at a time and assigning each character some numeric representation, or do you do it at the word level and do you assign each word a representation, like a numeric representation, and process at the word level? Character level is easier in some ways because there's only 26 or so characters that you're going to have to deal with, but then you have to build up complex words and then try to build meanings from that. So Google and most other places are now often doing word representations where they're assigning numbers to each word and then focusing on the first 10,000 most common words, or 50,000 words, or something like that. So this talks a little bit about how we encode and tokenize this text in different ways. There's now been more progress on more complicated ways of encoding text rather than just assigning each word a number here. So, last thing looks at bias in sentiment analysis. Just like we've seen in like facial recognition and other things, you have to be careful about your data and how your data is set up. Because often if you have poorly balanced data, you'll get a machine learning model that is unbiased, that will have some issues. Okay, so once you go through that first section and reading and analyzing, then we actually are going to do a kind of hands-on implementation here, where we're going to look at processing some text. So again, this is just, we import our libraries, we're checking for a TPU. I'm actually running this on a GPU here to run it a little faster, but it's not necessarily needed here. And then we configure the data. And again, I'm not going to go here. We're getting into some little more complicated code because some of the libraries right now don't have some of this built-in tokenizing and stuff set up quite the way we want it. So in this example, a lot of the code, there's more hard coding of stuff here, but this is just reading in the code. We're going to look at what is often called the hello world of semantic or language stuff, and this is the IMDb movie database. So IMDb is a very popular movie review database on the internet movie database. And so they have lots of reviews, and so this is a common data set that's available, and this is available through the Keras data set area. So this will just load it in and then process this. So this will take a little while to run and load in this information. But we'll load in 25,000 training and 25,000 testing reviews. So here's an example of the first part of a review here. And then each review is labeled either positive or negative review for this, 0 or 1. Then we do some processing, or we create this pre-processing routine to handle these words, and then we are going to manage those and assign them. So in this data set, there are just over 53,000 different total words. And again, we're going to look at some of the more popular ones. And so here's the printout. Now, one of the things you just have to watch when Python prints out words, we're storing them in a byte format, and so when it prints them out, it puts this B in front of the word, but the word is actually here. So just to kind of ignore the B's, the byte symbol in front of this. So the most common word is the, besides the space or the padding here, the, a, of, and, to, those. So those are our most common words. So we're going to limit ourselves to a vocabulary size of 10,000 words. So we're going to look at the 10,000 most common words and set those up. So we set that limit, and then we go through this. So words like this movie was clearly fantastic. So this is a pretty common word. So and movie in this database is very common too. So and was. So these are all assigned numbers like 22, 12. Clearly is not as common. That's word number 944. And then words that are very uncommon, like fantastic, spelled strangely here, will be assigned a number of 10,000. So any words we don't know will be assigned the number 10,000 here. We go through, and then we're gonna break these up, and we're gonna do. Then we're going to set these words up as tokenized. So each sentence is actually just a sequence of numbers, and each number represents one of the words in the sequence. We have to do some padding in here for some of our learning environments. So we have a bunch of zeros at the end of each sentence, so we can accommodate longer or shorter sentences as we go. So again, as you go through this, again, I don't expect you to understand all this code, but hopefully you can understand some of this, what the data is, how we're kind of encoding this data, and understand that. So now we're going to actually train the model. We're creating a model, so we have a special embedding layer, and then we have two recursive layers. Now we could use long short-term memory layers here, but we're using these GRU layers. And if you remember these GRUs, these are just gated recurrent net units, layers of those. So they're somewhat simplified versions of long short-term memory networks. So we have two layers of that, and then a dense layer. So this is actually not a very big network relatively compared to some of the image processing networks we do. In fact, it only has 1 million parameters in it when we're done. And much of that is tied to this embedding, where we're embedding the words in it. Then we're fitting this for 5 epochs and going through the training phase. So this is going to take a little while, but again, we should actually be spending more time on the training here than we do, but we're spending some time. So if you want to actually improve this, you should probably kick up the epochs to at least 10, if not more. And you can see our loss function decreases, but our accuracy does go up. We're getting up to 95% accuracy from what we're measuring here. And that's just predicting, is this review positive or negative based on the words in it. So, okay, now we're going to do some evaluation of the model for this. So here's some sample reviews. And again, I'm not going to go over this code too much, but focus more on what's being printed out here. We're printing out a review, and then we're doing a prediction of that review. So we're looping through a bunch of things. We're printing out a review, creating a review, and then printing out its actual label, whether or not it's positive or negative. And then we're running that through our model, and we're doing a prediction on it. We're running all the data through our model and doing predictions. So then we're printing out that prediction. And again, if that prediction is going to be a number between 0 and 1, and if it's above 50%, above 0.5, we're going to say it's a positive review. Otherwise, we're going to say it's a negative review for this. Now, so here's our results. Just some various examples of this. So like this is Portia Lilithane tries hard to lend some gravitas to this mawkish, gag-inducing, feel-good movie, but she's trampled by runaway sentiment. So that sounds to me, when I'm reading that, sounds like a very negative review. And so its actual label was a negative, and its score was just 0.1. And 0 is real negative, and 1 is positive. So that was rated as a very negative review, predicted negative and was negative. Where this is a positive review, and it got a 0.9, so the network thought it was a very positive review here. And this was actually given a 1, so the network was very sure that this was a positive review here also for this. So these are just some samples of this. So this is some ideas of that, and some last questions about the sentiment analysis and how it works. So hope you enjoyed this basic introduction to sentiment analysis.